Come in.
Hello.
Hello. Hi.
Hi.
How are you?
I'm Averill.
I'm Lorena. Nice
Lorena,
to meet you.
good to meet you.
Yeah. how are you?
Congratulations.
Well, thank you very much.
the
Welcome.
position.
Yeah.
Lovely office.
It is a little bit empty, but we're working on it. Yeah.
You ready to walk around a little bit?
I'm ready. So as I was a student, we had this building here on the right, which was what we had, and then a few years later, they managed to build this new facility here where we display core inside. We call it Vivo. And then we had this great donation by the Stoneburner family that allow us to build this garden.
That's actually their name?
Yes, that's their last name.
It's too good.
And the cool thing about this is that if you notice, and I guess we'll walk through it in a second, there are these chunks of rocks in there, and there are little stations that have numbers on them. So what they did was they went across Texas and they took representative samples, the rocks that you see, that tell the story about the geology that is displayed in Texas roads and outcrops. A lot of the researchers, and particularly the students, we spend a lot of time here because here is where the rocks are, right? So this is where lots of the work that we do happens.
Wow.
So yeah.
What are we looking at?
Well,
I'm overwhelmed.
We call it the CRC, right? It's our core research center. I like to call it the Indiana Jones archives. The first time that I stepped in here, I was literally overwhelmed by the view.
So you grew up in Venezuela, and what did your parents do?
My mom is Venezuelan. My father was an Italian immigrant. Both of them met back home, and they went to school, and they were tax people. They were doing taxes, so nothing to do with science or technology. But my paternal grandfather, who only had sixth grade, was one of these people who was self-taught. He went through the war in Europe, in Italy. And he, kind of self-reliant in the individual and self-taught. And he would take me out into the park or places, and he would always show me how things would work. And I think he was really the one who put that seed on me to try to figure out what was really behind things working. So actually I wanted to be an engineer at first before I wanted to become a geologist.
I see. And so in your degree, your undergraduate degree, was in engineering.
It was geological engineering, but just for the record, I forgot all my calculus. I went through it, but I forgot it. First, I thought I wanted to be a chemical engineer. And that's what I was studying until I met some friends who were in the geology department. And I was like, what am I doing here in the lab when I can be out there in the outdoors, looking at outcrops and rocks and having all this fun. So I switched my...
So that really was?
That's what it was. That's
being outdoors.
Yes. I guess I had the inclination since I was a child to be out. But then when I discovered that you could do science and be outdoors and have fun, that made it for me,
Wow. So why the move to Texas from Venezuela? What was it about?
How much time do you have?
We've got about a minute and a half, at least.
Yeah, well, I got my bachelor's degree really in geological engineering, back in the day. That was 2000. And then I got a job at the National Oil Company of Venezuela, called PDVSA, as an exploration geologist. I was in my early 20s. Then, 1999, Hugo Chavez won the election, the presidential election, and there was a lot of political turmoil at the time back home. So I was caught with other 20,000 people on that turmoil. And at some point, President Chavez fired 20,000 people one day. And I was one of them, you know.
Oh, okay.
So, yeah, so that triggered, you know, the search for what's going to be the next thing
His
for
loss
me.
was our gain.
I hope so. I hope so. But yeah, I landed here because there was a professor, Dr. Leslie Wood, who was doing a lot of consultancy in Caracas, and I was working with her at the time. And when she learned about what had happened, she encouraged me to apply to the Jackson School, and that's how I landed in Texas. Yeah.
Wow.
That's the story, or part of it.
Well, see, we're not even all the way down the aisle yet.
We still have,
it's over. So as long as I've known about this place, I've always assumed that economic geology is a euphemism for oil and gas. So besides oil and gas, what are some other economic concerns that you all might deal with?
I think it's true that the Bureau has been known for a lot of the work that we have done on research that affects or impacts the oil and gas industry, and this is true. But the Bureau really operates on that intersection between energy that goes beyond only oil and gas, the environment, and economics. So on the energy realm, we oftentimes think about oil and gas, but we currently are doing a lot of work on geothermal, for example, hydrogen. And then we also think about lithium, for instance, on brines and the Smackover and so on. We are doing a lot of work on that. On the environmental part of things, I don't think people realize how important water resources are sometimes. For energy also, we look at produced water issues in the Permian Basin. For human consumption, we also think about groundwater resources and how these are affected. We do a lot of work on coastal environments. We have a new program that is going very strong on wildfire risk in Texas and monitoring. And then we think about how all these things also impact the economic component for the state.
What do you think most people would be surprised to learn about this place?
I think the thing that still surprises me, and I'm here, is the wide range of topics and research that we do. One example, we have an active research program that is being funded by ARPA-E, where our researchers are actually making hydrogen out of ultramafic rocks. What they do is they look for rocks that are rich on iron, ultramafic rocks, for instance, and then they put them in contact with water and some catalysts, and you can ignite the production of hydrogen out of these rocks. So I find that to be fascinating because the implication of that is that in theory you could upscale that process so that you can induce the production of hydrogen in the subsurface where you find these big volumes of ultramafic rocks. We have a huge collection, and it's more than 2 million boxes of rocks. And we also have an extensive collection on cuttings that come from drilling wells. This core right here is from the Barnett Shell in the Fort Worth Basin. And we always, especially when we bring new people to the core facility who understand the relevance of oil and gas on unconventionals, we kind of show this a little bit to illustrate how the shale revolution really impacted energy in Texas and in the U.S. and in the world, right? So the Barnett Shell was the first play that George Mitchell, who was the founder and owner of Mitchell Resources, they understood that they could drill through this, and even though it's very tight rock, the pore network is very tight and the permeability is very tight, they understood that they could frack it. And through fracking, they were able to produce vast amounts of natural gas. So the Barnett was that first play, and that changed the
And
world.
we're talking 2000s, like late 2000s.
Actually,
May I touch it? I
sure,
mean, is that
absolutely. Actually, when I went to school, when I was on undergrad, rocks like this, we knew that they had hydrocarbons on it, and we would call them
because they come off on your hands, right?
it's rich in organic matter. You can see this dark color, and the petroleum system requires a source rock where the oil and gas will migrate from. But when I was in school, we were taught that you could not produce oil or gas from this just because it was too tight, right? You needed a reservoir, usually a sandstone. But the remarkable thing was that George Mitchell and his team spent probably 15 years trying to produce from this, 15 years failing
Wow.
on trying to frack this and spending millions of dollars unsuccessfully until they got the magic combination of the fracking fluid. And that was late 90s, early 2000s, right? And then the next thing was this was for natural gas. The next thing was to try to produce oil. And then this whole question about how big is a molecule of oil, can we produce it out from this? And now we are number one producers of natural gas, number three on oil. So core is essentially this, right? And what we do is, as we are drilling, we have special jacket that cuts through the rock, thousands of feet below surface. And then we extract these samples that we take to surface, and we use this to describe what is in the subsurface. So oftentimes we cut this in half. So we have a sample half and an observation half, and that's where we start to describe the different types of lithologies and minerals that we see. And that's where we have clues of, if we have a good reservoir rock, if we have a good source rock, and so on. We also take samples. We can do thin sections that we can see through the microscope, samples that we can send to the lab for chemical analysis, geochemistry, and so on. And then all these things put together tells us a story of how this rock was deposited or created millions of years ago. So in this case, I would guess, without being familiar with this core, that you had here some sort of sediment gravity flow influence in this, maybe something on deep water, and you can see the differences between this sample and this sample here. This one is more uniform, is more sandstone, like you can imagine the sand on the beach. Probably this is finer grain. Versus this one where you have an intercalation of that and darker layers that are finer grain. The Bureau itself is the oldest research unit of the university, actually. So we have been around since 1909. Of course, we didn't have this back in the day, but I can guarantee you that wherever you have a geologist, you have a bunch of rocks in an office or a cabinet. So if you really want to track down when we started to collect things, probably was 1909 or before, because all these people...
Even core samples like these?
Not core samples like this.
Yeah.
Back in the day, most of the work was linked to outcrops. Similar to what we saw on the rock garden, you would go out in the country and look for, big chunks of exposures on the roads or on the mountains that would allow you to go in there with a hammer and
easier to get to than
correct.
Right?
These ones here really started with as technology for drilling improved. And even today, it's not a trivial thing to extract core, because you have to stop operations just for the purpose of doing that. And you also risk the hole, because you have to put a lot of instruments and stuff inside the hole to cut the core and get it back up. So these operations, usually we're talking about millions of dollars each time you do those. So I show you, core that are like cylinders of rock that are extracted from, from these wells. But as we are drilling, as a byproduct, you have cuttings, which is the grind rock,
The
right?
sawdust of
Yes,
the
correct.
rock.
So then you can collect that, and you can have, in this case, is the depth interval. I think this here is the sample number, and then this here is trying to capture the depth interval from which these cuttings come from. And these are not ideal as the core, because the core shows the entire structure of the rock. But still, you can take this, put it under the microscope, and even in this box, you can see differences in color that are telling you a lot about changes in lithology. So looking at cuttings is something very, very valuable. I mean,
It's like a Home Depot, except everything's the same.
yeah,
All the packaging is the same.
kind of, but
It's unbelievable.
the thing that, I mean, as I have been telling you, you know, I have been involved with the Bureau for more than 20 years. And still, each time I walk into this facility, just by opening a drawer or looking at a new core, new ideas come up in terms of research questions and problems that are relevant for today, that we can actually take advantage of this archive of information and use it to find solutions and answers for those questions. I'm pretty sure there are not that many places like this in the world. And the relevance is that this is a permanent record of, you know, a lot of exploration activity in the U.S. Extracting this core is very expensive. So we're talking about, in terms of data value, millions of dollars in here. Storing this is also complex and expensive, and that's why companies usually give donations of material to us, because we have the capabilities to take care of that and preserve the data.
Can you put in a nutshell what your specialty is? I know it's deep water mixed siliciclastic carbonate systems. Did I get that close? Was I close on
Kind
that?
of. But nowadays he's sending emails, I have to say. That's my specialty.
But deleting emails.
Yeah.
So, and for the layman,
Yes.
what
yes.
really is that about?
Really, my scientific contributions to society had to do more with subaqueous landslides. You know, so you
Underwater?
can underwater.
Okay.
I spent a lot of times, and that's why I have glasses, interpreting seismic data, really high resolution, mapping and understanding the geometry of submarine landslides. And these submarine landslides can be thousands of square kilometers in area and can mobilize, you know, tons and tons of sediments. They're extremely important because they shape continental margins in very important ways. They have implications when you think about oil and gas exploration, but they also have modern implications today. For example, you know, telecommunications. There are a lot of submarine cables that go through the seafloor offshore. And sometimes you have, you know, interruptions of that, and oftentimes is linked to submarine landslides that somehow affect that infrastructure. They can also be linked to tsunamis. Think about, for instance, you can have an earthquake. And if you have an earthquake, you can have a rupture of the seafloor that will disturb the water column, but you can also trigger submarine landslides by the shaking. That could also trigger a tsunami. So that's kind of the relevance of that kind of research. We have around 20 researchers, from senior researchers to early career, doing a wide range of things and topics, and interacting a lot with Texas operators. That's also very instructional, you know, and very important for what we do. So we go out there and talk to companies quite often and show them our research. They know that we are a resource for them, especially small operators, you know, 3 guys drilling 2 wells in the middle of nowhere, sometimes they don't have the resources to have a big exploration department or a research unit. But some of these questions are basic research things that they need to understand to be able to make decisions. So they come to us with those problems, and we work with them to try to give them some framework and some help to advance their agenda on what they're trying to do.
So the director of this bureau is by definition the state geologist. Is
Correct.
that right?
Yeah.
So besides being director of this bureau, are there other duties of the state geologist that you have to perform?
I have been in the job for a month and a half, so I'm sure I'm going to be finding more about what that is. But one for sure is communication. As the state geologist of Texas, you need to be out there and communicate what our research is about and what the implications are. There is also an element where the director or the state geologist can be called by the ledge and other state agencies for counsel.
This would be like testimony.
You can
for
you can
committees?
be called. You can be called for testimony for committees and so on. So the executive committee, actually the executive team, where also the associate directors here are part of, oftentimes we have to go downtown to talk to all kind of people in different agencies. And we are consulted on a wide variety of things, from induced seismicity to water issues to oil and gas and so on. So that's pretty common, yes.
When I think about what is the oldest thing the university owns,
Yeah.
that's probably something in this room, right?
I'm sure we have some Cambrian stuff in here, but that's a good question. I don't know. We have
So
all
are we
these
talking
boxes.
millions or billions of years
No,
old?
millions of years. You know, so but
In the 9 digits
in the
of years,
in the
something like
yeah
that?
in the nine geologic. It is interesting, you know, how we think about time, and usually when I talk to family members or friends, this whole concept of billions of years, it's difficult to grasp, and sometimes we talk about thousands of years as, oh yeah, that was an hour ago, you know, in terms of the geologic record.
So I read somewhere that one of your interests is understanding how oil and gas fits into an energy transition. And I was at Energy Week at UT a couple of weeks ago, and I heard an interesting comment. Someone on the panel said that there never has been an energy transition. There's only been additions.
Yeah.
There are still societies that are burning wood and dung and coal, and we keep discovering new sources of energy and just adding them on. Is that right? Or are we actually going to make a transition at some point?
You know, the term has been, I think, kidnapped by, let's say, these animosities associated with energy. I think nowadays it's more accurate to say that we're really going through an energy expansion. You know, because when people, initially when people start to work or think about energy transition, they were thinking about a switch that you will flip and we will go from oil and gas to 100% renewables. And it doesn't work like that, you know. So what I think and what the data shows is that nowadays we need more of everything, you know. It is true that the percentage of renewables are increasing, but not close to what we need to provide the supply that society needs. Coming from where I come from, you know, and being someone who has traveled a lot, I can also tell you that we have to be careful because there are billions of people in developing countries that do not have access to the things that we are used to, right? And in their mind, the energy transition or the energy expansion or whatever term you want to use is not something that is a top priority for them. The top priority for them is to you know, to have a refrigerator or to have, or to be able to go to a hospital that has energy to operate. So I think it's extremely important to be aware of this and be sensitive to that. Because we only have one globe, one atmosphere, right? And therefore that's a reality that is there and that we need to face. That said, I like to be an ambitious person, and I think having ambitious goals is a good thing. I can understand how younger generations today, especially on developed countries, are pushing, the bar to want to go to a net zero future. And I think it's worth pushing technological advances and knowledge towards that goal. But I think it's wise also to frame that into a realistic framework, where data can actually inform us on what's happening. So is the transition going to happen? Something is going to happen, how and when, that's to be seen. And I think the oil and gas revolution associated with Shell is a good example, because as I was sharing with you before, when I was an undergrad, I was told that we could not produce oil and gas from shale rocks. Now we know that unconventionals are responsible for the production of oil and gas in the US, and how the Permian Basin, for instance, has completely disrupted markets during the last 20 years, right? And it was technology. Nothing stops technology, right? But it's really hard to foresee or forecast when those changes are going to happen. In the meanwhile, we need oil and gas, and we need to fuel society,
So what does the science tell us right now about the future supply of oil and gas because of fracking and whatever else might come along? As things stand now, can we go another 1,000 years? Greenhouse gases notwithstanding, do we have the oil and gas to burn? 20 years ago, people were rightly concerned that our supply had peaked, and that we were kind of at a tipping point, a point of no return.
Well, the 70s, right, with the oil embargo and all these things, people start to obsess with peak oil. When are we going to run out of reserves? And then in 2008, we hit that low. And then we have this ramp up with unconventionals in the US that are still going up, I don't think we're going to run out of oil and gas anytime soon, to be honest. I don't think the conversation right now is around peak oil as much as it is around peak demand. I believe that, and this is where the role of an organization like the Bureau is important. I believe that this is a good time, because we have been producing from unconventional resources now for over 20 years. I think this is a good time to work on trying to get new estimates of existing plays, but also looking a little bit outside the box with emerging plays in other basins to see what's the potential there, so that we can have well-informed things in the horizon, and estimates that can help us make decisions. But I don't think we're going to run out of oil and gas anytime soon.
And with fracking, what is the enlightened view right now of that? Does it cause earthquakes? Does it not cause earthquakes? Does it cause little earthquakes? I know it was an issue in the last presidential election.
Yeah.
So what does the best science tell us right now about the wisdom of fracking or not fracking?
I mean, the problem really is not fracking. The problem is produced water. That's the situation, for instance, in the Permian Basin. And what happens is that you frack the rock that doesn't produce the earthquake, really. And then the production, for each barrel of oil that you produce, you're producing sometimes 7-8 barrels of produced water. And this formation water is not clean water or drinkable water. It's kind of nasty water with a lot of things that you don't want to put on the ground. So the way we have dealt with that is we take that produced water and we re-inject that produced water into the subsurface. In the specific case of the Permian Basin, we used to do that on deeper reservoirs that were closer to the basement. And what we have learned is that the basement had some faults that were not active. But by re-injecting these fluids, we were increasing the pore pressure to levels in which we were reactivating those faults.
Oh.
So that's the real issue with seismicity. As we have learned that that's the problem, right? Then we are changing the things a little bit. And now we're not re-injecting as much on the deeper reservoirs, on the Ellenberger and so on. We're using shallower reservoirs that are away from the fault zones. And that brings also its own set of challenges and problems that are associated with legacy wells that are not, plugged properly. But I think the role of the Bureau actually is quite important on that respect because we host TextNet. We have more than 200 seismic stations across the state that actually monitor earthquake activity, and we provide real-time information in terms of what's happening with earthquakes across the state. In addition to that, we look at the data, and as I was explaining before, our researchers here, and we have wonderful researchers with TextNet and CSER, look at that data, put that data into context. They look at what's happening in the subsurface, and then we try to understand what are the mechanisms associated with this seismicity, how can we try to mitigate these things. So that's the role that we have as the State Geological Survey as well.
Last question.
Sure.
What is your vision for the Bureau of Economic Geology going forward?
You know, I was talking about some of my guiding principles recently on an old staff. And essentially, we're here to serve society. We're here to serve Texas through the knowledge that we have of the earth as geoscientists, So our role as the State Geological Survey of Texas is extremely important, and it has been important for the past 100 years. Now we have 4 new initiatives that one of our associate directors, Mark Schuster, initiated, and that we will continue. One of them is in geothermal energy, natural exploration of hydrogen and helium, going to this emerging energy component of things, water resources and mineral exploration of critical minerals, but also aggregates, which are so important for construction in Texas. So we are the State Geological Survey of Texas. In terms of research, I think it has always been important for the Bureau to stay in tune with what is needed out there. I think for an institution like the Bureau, we need to stay in tune with what are the key questions that we need to be working on to benefit society as a whole. So our research portfolio needs to stay flexible, and we need to not to overreact, but to change when it's appropriate to get aligned with those needs. The other thing is we are part of the Jackson School of Geosciences, so we have an educational mandate, and this is close to my heart. I think it's important that we share our knowledge and our vision with new generations, particularly now when we are seeing worldwide that there is a decline on the enrollment of students on STEM fields, and particularly on geosciences. And I think that's a huge problem because anything that we do, we need the subsurface. And for that, you need geoscientists to work on those problems. We're part of the University of Texas, so interactions with UT Energy Institute, the KBH Center, Energy Center, and so on, it's also important. And then I think the Bureau is about people. Being in tune with what people need for their professional development, to be happy, to feel that they have a mission and that they are fulfilled with coming to work every day is one of my priorities. 3 years ago, I got a postdoc who started to work on evaporitic sequences in Texas. And, we found incredible material here that we have been using to try to better understand energy storage potential in terms of hydrogen or natural gas in salt caverns, And those rocks were here untouched, almost untouched since the 1980s.
Wow.
So that's the value of really preserving this facility and the data that we have here.
And just between you and me, have you found the Lost Ark?
I'm still looking.
Speaking of the 1980s.
But maybe somewhere here, I haven't checked everything.
Yeah, you surely haven't checked every crate.
Yeah,
Here's
correct.
a crate right here. It's about the right size.
Who knows what is in here?
That's about it.